Hello out there, all you fine folks. We're still looking at the 2002 Pascal paper. And so we're going to be taking a look at question number 22. That's where we're at. In a school, 500 students voted on each of two issues. Maybe issue A and issue B. Who knows what they were. Of these students, 375 voted in favor of the first issue, and 275 voted in favor of the second issue. So this says nothing about their overlap. So some of these, in fact, a lot of these might have voted for both. Who knows? And 40 students voted against both issues. How many students voted in favor of both issues? Okay. So this strikes me as actually a Venn diagram-y sort of question. So let's draw a picture of what exactly is going on as a Venn diagram. So we have the total school, also called the universe. The universe is the total amount of things we're talking about, and it's 500 students. Then we have the students who voted for the first issue. I'll call that issue A. And then we have the students who voted for the second issue. We'll call that issue B. And we're suggesting that there is some overlap. So we have a whole bunch of students in here. Students who voted for A, students who voted for B, students who voted for both, and that's what we want. And out here we have 40 students who didn't vote for any of the two issues. So we're told this one's 375 and this one's 275. Okay? So we're going to let X be the number of students who voted for both. So that little overlap section is going to be X many students. And we have a total of 375 students in the blue sphere, or in the blue circle. So if we want to put X students in here, we'll have 375 minus X students outside. Let's give these actually some colors so we can better illustrate this. So we have 375 students there, but inside here we have X students who voted for both. Then over here, what's left over is 375 minus X students. So in total, I get the 375 students who voted for A. And over here, we have 275 students in total inside the red circle. X of them are over here in the overlap. So we'll represent in green the remaining students, and that's 275 minus X students. So now there's no overlap between our sections. Our total of 500 students is these 40 students out here in black, plus the purple students in here, plus the orange students, plus the green students. Okay? So the reason we couldn't, if I just quickly sketch this before, the reason we couldn't add them up beforehand, because of that pesky overlap, the very thing we're trying to work out. All right, we have 275 students here, we have 375 here, and 40 here. You would think that this should add up to all the students. So 40 plus 375 plus 275 should be 500. But if we actually do the calculation over here on this side, 375 plus 275 plus 40, that's a total of 690 students. We have counted some extra students. We've counted these students both as part of the blue circle and part of the red circle. So you can't add them all up to be 500 and have some overlap. So that's why we broke them down into the purple just voted for the first issue. So purple is students who only voted for A. So they voted for A and not for B. Green is the students who only voted for B. So they turned down the first option and were for the second one. And X voted for both. And now we can add these up. These are what are known as disjoint sets. There's no overlap between them. So 40 plus 375 minus X plus X plus 275 minus X. This should be the total number of students, which is 500. Okay? Minus X plus X minus X, we're going to get a minus X here. 40 plus 375 plus 275, I already mentioned that is 690. So we can rearrange this. We can get X over here on the right. We get 690 minus 500. And that gives us 190 is equal to X. And that's what we wanted. We wanted the students who voted for both. So, you could have just jumped in and done this question by saying, well, they should all add up to 500, and we've just double counted only the students who voted for both. So you didn't need to draw this Venn diagram, but I like sorting it out. I like having a visual picture, and Venn diagrams will come back if you ever do some finite math. That often happens in first year college or university. So Venn diagrams are very useful tools. So how many students voted in favor of both issues? C, 190. Okay. So we're moving right along through part C here. Got 3 questions left to go on this contest, and hopefully I will see you guys for question number 23 in the very next video. So long for now.